Modern power generation is a vast and varied landscape. On the coastlines and across the open plains, we build massive structures to harvest the air itself. Inland, colossal concrete barriers are wedged into river valleys, capturing the immense, driving weight of millions of gallons of falling water. And then there is the intense thermal reaction of a nuclear power plant, generating extreme heat far away from the elements. Looking at a wind farm, a dam, or a reactor, it is easy to assume that the wind, the water, or the uranium is the direct source of your electricity. In reality, none of these fuels produce a single spark of electrical current. They only produce raw movement. Even a multi-billion-dollar nuclear reactor functions as a highly specialized, expensive boiler. Without a specific intermediary machine to translate this chaotic movement into usable power, that raw natural energy remains useless to the electrical grid. That translator is the power turbine, the hidden engine of the modern world. Whether the input is pressurized steam, combusting gas, rushing water, or wind, this single machine acts as the mandatory bottleneck for all of them. Fuel does not make electricity. Spin makes electricity. And the turbine is what provides that spin. The process begins at the front end of the machine, where the moving fluid, be it steam, gas, or water, violently strikes the turbine blades. To capture every ounce of energy, a heavy outer casing and a governor dictate the flow of the fluid, maximizing its physical impact against the rotor. This highly controlled flow forces the internal rotor to spin at incredible speeds. This rotational energy then tracks down the length of a solid central shaft. Massive bearing collars are required to hold this rotating shaft perfectly steady as it undergoes extreme physical stress. This mechanical half of the system serves one primary function: trapping the chaotic energy of nature into an organized, rotating mechanical bridge. The rotating shaft crosses over from the mechanical side into the electrical side, the generator. Here, the principle of electromagnetic induction translates that mechanical spin into electricity. Inside the generator, the end of the spinning shaft acts as a magnetic rotor. This magnet spins rapidly inside a stationary perimeter of copper stator windings. As the magnetic field rotates, it physically pushes and pulls electrons within those coils, inducing a pulsing AC voltage. This specific magnetic interaction is the exact moment physical kinetic energy becomes electrical power. The raw voltage leaving the stator coils is not yet optimized for its journey to our homes. It must first pass through transformers, which step the voltage up significantly. This high-voltage conversion allows the electricity to survive the trip across the transmission grid without being lost to heat. Beyond the abstract concept of a digital grid, the system is a strictly physical machine, directly anchored to the heavy, spinning turbine. Power operates as a live relay, a continuous, unbroken chain of physical, kinetic movement stretching across the country in real time. Every time you plug a device into the wall, you tap into the physical rotational force of a turbine spinning hundreds of miles away.